This is our last unit. We're going to discuss compliance. So, we started the semester talking about how to develop these policies, the different parts of policies, and then we went into specific policies, talked about the baseline standards and the policies that we could incorporate for the 7 parts of the IT infrastructure and risk policies and so forth and so on. And finally, we talk about enforcing compliance. We talked about enforcement last week, but we talk about how to audit for compliance or how to manage compliance in this unit. So there are obviously ways that we can enforce, or I'm sorry, that we can automate compliance with technology, and that's mostly what we talk about in this unit. Throughout the entire semester, we've been talking about this relationship between the policy, the standards, the procedures, and the guidelines. And mostly in this unit, we talk about standards. Specifically, a baseline is a starting point or standard. So we talk about these baseline standards, which basically define what we wanted, how we're going to enforce that policy, or how we're going to ensure that that policy. So what are the technical standards that we can implement that support that policy that we've written? So we define that. So that could be minimum security settings, which include things like certain protocols that we require, services that are required or not allowed on our network, different types of account policies, things like that. And we can use these things to measure compliance and compare the settings to the baseline settings. So in other words, if we define that for example, a Windows server has to have certain settings in order to be compliant with our policy, we can then use that baseline standard to audit that server to see if it complies with the baseline setting. So it gives us a very objective way to ensure that our systems are complying with those standards. Now, again, we've already defined at this point, when we reach this point, we've already defined those baseline standards. So we know what they should be, and we're using those baseline standards to configure our servers at this point and to ensure that those servers are complying with those baseline standards. If we comply with the baseline standards, then it's reasonable to assume that we're complying with the policies. So applying baselines improves security. Our book talks about that. There's less chance of missing a setting on an individual system, reduces total cost of ownership, saves time over individual configuration, reduces troubleshooting time. We're going to talk about how to do this in just a minute. So once you define these baselines, the important thing to remember here is when you've got this baseline, you're kind of taking the thought process of installing an operating system away. So you're basically saying, well, if you hand somebody a computer and say, install Windows 7 and make sure it's secure, how do you do that? What are the steps that you could take? How do I objectively measure whether that's a secure implementation of Windows 7 in my organization, as an example? But by having baseline standards, it tells us, okay, here's all the things that Windows 7 should have in order for it to be to comply with our policy and to be considered secure and eligible for deployment in the organization. So our first step is to install the operating system and any applications that we require, configure user settings to the baseline standard, configure security settings to the baseline standard. Then we image that system and we can deploy that image throughout our organization. Let's talk a little bit more about how imaging works. So what is imaging? We start with, let's say we've got a whole bunch of computers in our organization. There could be hundreds, thousands, tens of thousands of computers. And the challenge is, we develop these baseline standards. How do I make sure that every single computer implements those baseline standards or has those baseline standards? Well, one way we could do that is take a master computer or a computer that, the first one that we install, and we can very carefully set it up with the operating system, applications, and security settings that comply with the baseline standard. And that could be following a procedure. So there could be a procedure that says, here's all the stuff that you have to go through and install and change and set and all that sort of thing. So somebody could go through and do all that, configure that system. Somebody could do a QA to make sure it's all configured properly. And then once we've got that configured system, we can capture an image of that source computer and send and basically apply that to our target. So we capture an image, and then we use that image to build all of our systems. So they all are an exact duplicate, an exact clone of the source computer. Now, one risk here is if you make a mistake when you're initially configuring the source computer, that mistake is going to replicate to every computer to which the image is copied. So that's definitely a risk. That's why you have to be extra careful, have an extra set of eyes that does some kind of QA. In businesses that I work with, we always have a QA process where when somebody builds a system like this, somebody else has to do a quality assurance where they go through the checklist and sign off on everything a second time, just to make absolutely sure that all of the procedures have been followed and that the system complies with the baseline standard. Another way to ensure compliance is to use Active Directory or group policy. So once you have the your baseline standards, so some of these baseline standards you can codify into group policy for Microsoft Windows and a Microsoft Active Directory environment. So how this works, we start with our, we have our main domain, which in this case could be abccorp.com. So that's our domain, and then that domain may have some branches. So for example, we might have the PCI servers organizational unit, the research and development organizational unit, and the HR organizational unit. And each one of those have their own needs for security policy. But some of our security policies would apply to the entire organization. So if you create a security policy, for example, a secure password policy, you know that everyone in the organization should have a secure password. So you might create a password policy in Active Directory using group policy, and that could apply to the abccorp.com domain. But then each one of these organizational units could have their own group policy that apply at their own level. So the PCI servers could have a PCI DSS policy that's applied in their group. The research and development could have the policy in their group. There could be a HIPAA policy that you apply to the HR group, and so forth and so on. So the secure password policy would filter to all of the organizational units, but each one of these organizational units could have their own subset of policies. So for example, you wouldn't need the PCI policies to be applied to HR and to R&D. And likewise, you wouldn't put R&D policies in the PCI policy. So it's helpful to be able to break this up into different organizational units. So group policy is a very powerful tool for security policy compliance. It allows us to write or take those policies that we've created. So, we've created these policies. Those policies, we've set forth some baseline standards, and we can codify those standards into Active Directory group policies. Active Directory will then enforce the compliance to those policies by applying group policy based on the user's group or group membership or what organizational unit they're in. So definitely a powerful tool. Our book also talks about compliance monitoring and the difference between compliance monitoring in the public and the private sector. So in the public sector, public sector would be any company that's publicly traded or is regulated. So even if it's a private company, if they sell to the government or they work with the government or they're a government contractor, they would fall under under the public category. So they have regulations that might require reporting on compliance with policies. There might be some compliance laws that require specific reporting guidelines, and governmental laws that stipulate when reports are due. So there may be some regulatory requirements in those cases. Contrast this with a private company. In the private sector, the reporting requirements are set by the owners of the company, not the government, not regulations. So it's definitely not as structured. Government compliance laws may not apply. So there's no statutory requirement to do this. And problems often go undisclosed. So you don't really have to tell anybody that you have these issues. So I've talked about some ways that we can try to use automated enforcement for compliance for IT security policy, but we also have to do auditing periodically to make sure that people are actually complying with these policies. I talked about how we had these baseline standards, and the baseline standards would tell us how systems should be configured, what the settings should be. But the problem is, how do we go out and make sure that every system complies with that standard? And in some organizations, that's a pretty daunting task. If somebody said to you, hey, we've got 10,000 workstations, or we've got 2,000 servers in the data center, and we need to make sure they're all in compliance with the IT security policies, that's a lot of systems, and it's a lot of work to go out there and audit those systems. So one approach could be random audits. You could pick certain machines to do audits. But our other option is to use automated security policy compliance. So there's automated systems that you can put in place to manage this. In our book, they talk about some benefits to doing this, to using automated security policy compliance. The first thing they talk about is cost reductions. Full-time employees can be retasked to other things if you don't have to waste your time doing this, IT audit compliance, or compliance auditing and all that stuff. It frees people up to do something else. It's a pretty obvious benefit. Efficiency due to computers doing the policy compliance monitoring. So obviously computers are a lot faster. Humans can't hope to do this compliance monitoring across 10,000 or 50,000 systems like a computer can. Computers can do it in seconds. Humans would take, an hour to do that, where a computer could take a couple seconds or less to go out and audit different systems. So you can literally audit every single system in the organization with these automated tools, which we'll talk more about in just a few minutes. Better reporting functions and data capture. It's more consistent, that's for sure. Online real-time compliance reporting and monitoring, so you can see what's happening in real time. You could almost in real time see when a system drops out of compliance. So if somebody installs some software they're not supposed to, or starts a service that they shouldn't, or is hosting some kind of service that they shouldn't be doing, you can almost immediately see that. Increased accuracy. You're not relying on humans to document all this stuff. Computers rarely make those types of mistakes. So definitely a lot of benefits doing automated security compliance monitoring. So what are some tools that we can use to do that? In the Windows world, we've got a few. There's the Microsoft Baseline Security Analyzer. This is a free tool that you can download from Microsoft. You can install in any Microsoft system, and it will scan systems for security vulnerabilities. It downloads basically a config file that describes all of the vulnerabilities that it should scan for, all the recent release patches that it can check for. It scans for all of this stuff, and then it keeps a history and reports any variations from the baseline. So this is certainly one option, and it's I don't know how scalable MS Baseline Security Analyzer is. I know you could do it on individual workstations, but I'm not sure if you would want to use that on an entire network. There's the Windows Server Update services, and of course this is something that's a server side service. It just basically allows you to download patches and updates to a patch management server. You can test the patches first, and then you can use this to deploy patches. So the idea is, instead of all the computers in your organization downloading patches directly from Microsoft, instead they're getting those updates from the Windows Server Update services, and then they're installing those patches and those updates. And that way you have some control over what patches and updates get installed. Again, one of those things, in the baseline standard, you might define what our patches and updates are appropriate, and you may also have a policy that says that patches should not be installed until they're properly tested, to make sure that there's no compatibility issues, that it doesn't break any of the software in your baseline. So certainly you can manage all that with Windows Server Update services. Systems Management Server, or SMS. This is older. I think this came out in Windows 2000, but it can query systems for vulnerabilities using kind of the same thing as MBSA, but you can do it across the network. But a more modern version of this is the System Center Configuration Manager, which can do everything that SMS does, but it has some enhancements. You can use this to deploy entire images of or operating system images if you need to. So definitely a little bit better than SMS. Now this is the Windows world. So these are some tools that are available from Microsoft. That you can. I think MS Baseline Security Analyzer, Windows Server Update services, they're free. The System Center Configuration Manager, I think you have to have certain licensing in Windows Server to use that. But they're all acquired through Microsoft. They're part of the Microsoft Windows Server suite of products. So it's all integrated with the Microsoft world. Not all of us have just Windows. I mean, most of us have Unix or Linux servers in our organization. So in the Linux and Unix world, a couple of automated compliance tools. One would be Nessus, which is a vulnerability scanner. And it works on more than just, it runs on Linux, but you can also use it to scan Windows systems. So you can use it for both. It's a tool that runs on Unix or Linux, but it can be used to monitor compliance across the organization and also the Windows world. Nessus is a pretty powerful tool. A lot of people use Nessus. Definitely a good tool. Similar to that, we have Nmap. Nmap's a little simpler. Basically, Nmap scans the network, or scans hosts on the network for open ports. And when it finds an open port, it can try to identify exactly what's running on that port, what version of the software it's running. So you can use Nmap to scan your network to see if anyone's running services that they shouldn't. So you can check for file sharing services, or you can check for peer-to-peer sharing services, for downloading movies and things like that. Common ports for gaming and things, things of that nature. So Nmap can certainly help you fingerprint uh, what's happening on certain workstations. So you could scan your entire network with Nmap um, to see what services might be listening on various machines. You can also use Nmap in the server world. One thing that you probably would want to do for IT security is make sure that if somebody were to use a tool like Nmap, they would not be able to figure out what version of various software packages you're using. So you wouldn't want somebody to be able to figure out what version of SMTP you're using, say on a Linux machine, or what version of Apache you're running, because that helps them understand what your vulnerabilities might be. So to that end, you could use Nmap to see if Nmap is able to identify all that stuff. And if it is, you know that you need to do something to obfuscate that, so somebody wouldn't be able to figure that out if they were running something like Nmap. So certainly a pretty valuable tool that you can use for automated compliance. EI, Digital Security Retina, is a commercial application similar to Nessus. It basically is a vulnerability management tool. It again, just like Nessus, it can scan more than just the Linux and Unix world. It can also scan Microsoft. You have to install it on Linux, but it can scan Microsoft servers and Microsoft workstations. It can also do some patch deployment and verification. Another one is Security Admin's Integrated Network Tool, or SAINT. Again, this is another commercial product, but and again, it has to run on Unix or Linux. Actually, I think this could run on Unix or Linux, just like EI or Nessus. But once again, it can also test or do scanning against Windows platforms as well. Also, Saint is a little different than the other ones because it can do you can use it to do penetration tests. So you can do some pen testing with Saint. And the last one that our book talks about in the Unix or Linux world is Symantec, which is similar to everything else that I talked about. Again, it's a commercial product. It can scan multiple different operating systems. It has some monitoring tools. You can deploy patches. So again, very similar to EI and to Saint. Nessus, I think, we said it was a really good tool. Nessus, I think, is kind of the industry standard for vulnerability assessment, but it doesn't do patch management. So something like EI or Saint or Symantec can also do that patch deployment and patch management. But again, you can mix and match some of these tools. So in the Windows world, we've got, a patch management service that comes free with Microsoft Windows Server. So if we had something like Nessus, we could allow Windows to do the patch management, and Nessus would be doing the vulnerability scanning. So by no means do you have to have all this stuff in one tool. You can, deploy different tools. So we talked about both Windows and Unix tools. In this unit, we also look in the book, our text also discusses how important change management is for compliance. Once you go out and set up all these computers and everything complies with the baseline standard, the only way anything would deviate from the standard is if there's changes. And changes can be bad. Change is good, obviously, for a lot of reasons. In IT, things are constantly changing. But the flip side is, with things changing so quickly, sometimes changes can have adverse effects on not only the network and our software, but sometimes those changes might have an adverse effect on our baseline security standards. So, somebody might have to change something that is in our baseline or make a change that deviates from that baseline. So change management is important to help us maintain compliance because, it hopefully would trigger or force people to report these changes before they make those changes. And if they fail to do so, there would be some ramifications for that. And of course, you would probably have some kind of change management policy. Our book talks about using tools like configuration management databases, use a change control work order database so that you can request to make a change, and then that change could be approved or not approved or tested and things like that. And you can use those databases to do tracking, monitoring, and reporting of configuration changes. So it's helpful to know what changes have been made on the network and how they might affect these security policies. And of course, change management is a whole other area of IT that you can talk about for other reasons as well. But in this class, we concentrate on its ramifications with IT security policy. So, of course, having all these tools and making sure you have strong change management policies will help maintain compliance with your IT security policy. Some additional IT compliance tools that you'll see in the book that I'll talk about. SCAP is one. This is a pretty powerful set of standards. They were developed by NAST, which we've talked about before, for FISMA. Again, we've talked about all these regulations before, but it offers a standardized way to maintain compliance with IT security policies. Your book gets into a little bit more detail. I know it's a little bit confusing, but and there are lots of commercial tools that implement SCAP. The important thing to understand that SCAP is not a tool in itself. SCAP is a set of standards that you can implement using tools that are commercially available, or even open source. There's a few open source packages that can do some of this stuff. And it's kind of like a checklist. It's like an automated electronic checklist. Most of it relies on XML. You'll see that in the book. But basically, it's a set of standards that can be implemented. So in other words, if you have security tools that implement the SCAP standards, you know exactly how it's going to work, and you know exactly what its capabilities are going to be and how it's going to check for compliance. And you know it's interoperable with different tools. So lots of reasons that we like standards. You know, your book uses the example of HTTP as a standard and why we use standards like that. But the important thing to understand, again, is SCAP is a standard. It's developed by NAST, and there are tools that you can use that implement those standards. SAINT, which I already talked about, and EI, which I already talked about, both implement SCAP. And there are some other software packages that your book talks about, like Tripwire, Control Compliance Suite by Symantec, which is geared mostly towards the federal government. There's a HP SCAP scanner by HP, or SCAP scanner by HP. So a couple different options out there for SCAP. Another one is SNMP. This is kind of a legacy standard. One thing you have to be careful with SNMP. Well, I'll talk what SNMP is. It's basically a way for querying the configuration for devices on your network, and even being able to change configuration settings over the network. So it's simple network management protocol. There were a couple different versions of SNMP. The first one was SNMP version 1, and it was a pretty open standard, so it's not very secure. So if you are going to implement SNMP, it's best if you're not using version 1 of SNMP, and instead implement some version like 2 or 3. They can give you authentication, and it has confidentiality. It's got all the security features that you would need, but without, in SNMP version 1, anybody could go out and query any device that supports SNMP and read its configuration and even make changes to its configuration. So you can see how that might be kind of dangerous. But with SNMP version 2 and 3, it's a little bit more powerful. It has authentication and things like that built in. So that's certainly a good option. And you can use SNMP to basically get the configuration details for your network devices. So you can go out and scan and get the details on what the configurations are on all those devices, so you can use that to verify compliance with IT security standards. Web-based enterprise management is basically, again, it's another standard, not all that different from SCAP. SCAP was standards for creating tools, but WBEM, or web-based enterprise management, is standards that allow that basically define how to consume that information over the network. It's basically the language used to exchange data among different platforms for management of systems and applications. So it's a set of web services that you can use to query. So not that much unlike SNMP, but it uses web services instead of its own protocol. So it rides on HTTP. There's a couple commercial tools available that your book talks about. Again, it's not, web-based enterprise management. It's not a product itself. It's simply a set of standards that you can use, and that products implement in order to go out and get those that information. WMI is Windows Management Instrumentation. It's basically Microsoft's implementation of web-based enterprise management. So that's how you would do this in the Windows world. So as an example, WMI lets you automate tasks using something like VB-script or the PowerShell, which supports VB.NET. So you can script all of these. Basically, you can script the going out and getting all of the settings on various servers and workstations and putting that into some central database or something like that. So WMI is what they use in the Windows world. And our book also talks about digital signatures, which I'll talk about in more detail. But the idea behind a digital signature is it makes sure that when data is exchanged between different systems that it hasn't been modified. So why is this important for compliance? If you're deploying patches as an example, you might want to make sure that those patches are the patch that came from Microsoft and it hasn't been adulterated in transit before the user went to install that patch. Digital signatures are required in some organizations for all the software that's installed. We've got all this software that's provided by vendors. You want to make sure that software that people are installing is the actual software that came from the vendor and not some modified version that contains a virus. Even if it's just executables, or it could be installers, ActiveX controls, all that stuff, we might want to require digital signatures. And again, this helps us maintain this our IT security compliance. In our textbook, they've got a pretty detailed chart on how digital signing works. I'll briefly go through it here for you. So for digital signing, we start with our data. We then hash. We use a hash function to generate a one-way hash. So in this case, maybe this is our one-way hash 1011001111, etc. And I'm sure from your cryptography classes, you're probably familiar with what hashing is, what a one-way hash is. And again, I'm describing here how integrity works, basically. So we get our hash, then we take that hash for a digital signature. You take that hash, and we're going to encrypt it with a private key. So we take our private key and we encrypt the hash, and that gives us our signature. So we start with our hash, which any block of data, if you run it through a hash algorithm, you're going to end up with a fingerprint, basically. And then you can take that hash or that fingerprint and you can encrypt it with your private key, and that gives you the signature. And then we'll talk about certificates later, but you can take the certificate and the signature, and the certificate basically says who you are. So the certificate is basically, here's who I am. Here's the name of my company. You can go and verify that I am who I say I am, etc. So usually a third party provides the certificate. And then we have our digitally signed data. We then take that data and we transmit it across the network to some other system. That system is then going to split it. They're going to take the data that's in the payload and they're going to take the signature. So we have that signature. The data goes through the hash function. So we take that data. It's the same data that's all the way up on the left-hand side. So the exact same data. And we're going to run that hash function to get the hash value. You can see that that this hash up here that was on the left side is we're going to get that same hash when we take that data. Now, if that data was modified at all in transit, this hash is going to be different. Now, how do we know? This hash was sent along with the data. So how do we know this person did not, change this hash while it's in transit along with the data? This is the point of a digital signature. So we have the digital signature. How do we get the actual hash to compare it? We take the public key. So we take the sender's public key, and that comes from the certificate. So we go to a certificate authority and we go get their public key from the certificate authority and say, what is this? This is who they say they are. Give me their public key. And then we hash, we encrypt this hash with their public key, rather decrypt the hash with their public key. And that gives us the hash code. And then we can compare those two and see if they're the same. And if they are the same, then we know we're good. We've got the same file that hasn't been adulterated in transit. So some best practices to kind of wrap this up for you a little bit. And this has been a pretty short presentation, this last one for the last unit. But some best practices that just to leave you with. We start with a security policy. We've been talking about that all semester. We begin with a policy, which is again much more brief than all the other stuff that we talk about, but the policy is the goals. This is what we want to achieve. And then we're going to create a baseline. based on that policy. So we're going to create baseline standards that support that policy. So ways that we can support that policy, technology, standards, all that stuff that's going to support that security policy. We're going to audit systems regularly to make sure that they've implemented that baseline policy. Hopefully we can automate that as much as possible. So if we can automate that auditing, computers can do this a lot faster than humans can. And finally, we're going to manage changes to make sure that people aren't deviating from that baseline policy. And that's all I have. So I tried to keep it just under 30 minutes. It looks like I hit the mark. If you have any questions, please reach out to me. And this concludes all the material for the semester.